Alright, let's get right into it. Number 10. One of the largest stars ever discovered is currently unraveling itself so violently that some astronomers believe it may have already exploded, and we are simply too far away for the light of its death to have reached us yet. Canis Majoris, a red hypergiant located approximately 3,840 light-years from Earth, is estimated to be roughly 1,400 times the diameter of our Sun, so massive that if placed at the center of our solar system, its surface would extend past the orbit of Saturn. Astronomer Roberta Humphreys at the University of Minnesota has studied the star extensively since the 1970s, confirming through Hubble Space Telescope imaging published in 2007 that it is ejecting massive, irregular arcs of gas and dust from its surface. This kind of extreme, unstable mass loss is considered a hallmark of a star in its absolute final stages of life, and Humphreys and her colleagues have stated the star could explode as a supernova or hypernova at essentially any time on an astronomical timescale, potentially within the next 100,000 years, or, given how unpredictable its current instability already appears, considerably sooner. Because the star sits nearly 3,840 light-years away, if it exploded today, we would have no way of knowing for thousands of years, meaning the death of one of the largest stars ever catalogued could already be sitting in the light currently traveling toward Earth. Number 9. One particular star's rotational axis appears to be aimed almost directly at our solar system, and when it dies, some researchers believe it could unleash a concentrated beam of radiation capable of reaching Earth with essentially no warning. WR-104 is a Wolf-Rayet star, an extremely massive, rapidly evolving star nearing the end of its life, located roughly 8,000 light-years away. Astronomer Peter Toothill at the University of Sydney, using the Keck telescope in Hawaii in 1999, imaged the star's surrounding dust in a distinctive pinwheel shape, and further analysis suggested its rotational pole may be oriented nearly face-on toward Earth. When Wolf-Rayet stars die, some detonate as hypernovae, releasing narrow, highly focused beams of gamma radiation along their rotational axis. Astronomer Grant Hill at the W.M. Keck Observatory has stated publicly that the chance of a directly damaging alignment remains low, and later research by physicist Andrew Higgins in 2017 argued the true orientation is likely off-axis enough to spare Earth. But the star is expected to die within the next few 100,000 years, and because light takes 8,000 years to reach us from that system, WR-104 could have already exploded in the time since early human civilization began, and we would have absolutely no way of knowing until the light and potentially the beam finally arrives. Number 8. In 1843, a star briefly became the second brightest object in the entire night sky, survived an explosion that should have destroyed it completely, and astronomers now believe the same star may already have finished the process of dying, with the evidence for it still years away from reaching Earth. Eta Carinae, located roughly 7,500 light-years from Earth, underwent what astronomers call the Great Eruption between 1837 and 1858, documented by astronomer John Herschel, who recorded the star outshining every star in the sky except Sirius, despite its extraordinary distance, before fading dramatically over subsequent decades without actually being destroyed. Modern Hubble Space Telescope imaging, including detailed analysis published by astronomer Nathan Smith at the University of Arizona in the 2000s, confirmed the eruption ejected 10 to 40 times the mass of our Sun into space, evidence of a star under catastrophic internal stress. Eta Carinae is a binary system containing a star roughly 90 times the mass of our Sun, among the most unstable massive stars ever identified, and astronomers widely expect it to eventually explode as a supernova or hypernova. Given its distance, if that explosion already occurred at any point within the last 7,500 years, the light confirming it is still crossing interstellar space toward us right now, meaning one of the most closely watched unstable stars in the galaxy could, at this very moment, no longer actually exist. Number 7. One star system has erupted in a survivable nuclear explosion on its own surface at least 6 separate times since humans began recording it, and astronomers now warn one of those repeated eruptions may eventually be its last, an ending that could have already occurred without our knowledge. RS Ophiuchi, located roughly 5,000 light-years away, is a recurrent nova, a binary system containing a white dwarf pulling material from a companion red giant star. Astronomers have documented eruptions in 1898, 1933, 1958, 1967, 1985, and 2006, each time the white dwarf accumulating enough stolen material to trigger a runaway thermonuclear explosion on its surface, briefly brightening the system dramatically before settling back down, confirmed through decades of observational records maintained by organizations including the American Association of Variable Star Observers. Astronomer Bradley Schaefer at Louisiana State University, publishing research in 2010 examining the system's mass, calculated that the white dwarf inside RS Ophiuchi is dangerously close to the Chandrasekhar limit, the mass threshold beyond which a white dwarf detonates completely in a Type 1a supernova rather than merely erupting on its surface. If one of these repeated eruptions finally pushed the white dwarf past that threshold at any point in the past 5,000 years, the entire system would have been destroyed in a single, total explosion, and we would not know until the light of that final detonation, indistinguishable at first from just another routine eruption, finally reaches Earth's telescopes. Number 6. In 1866, astronomers watched a completely invisible star suddenly appear in the night sky, brighten dramatically, and then fade away, only to discover it happened again 80 years later, and researchers now believe it is due to repeat the exact same event again within the next few years, a countdown some believe may have already reached zero. Eta Carinae Borealis, nicknamed the Blaze Star, is a recurrent nova located approximately 3,000 light-years from Earth, first documented erupting in 1866 by astronomer John Birmingham, and again in 1946, a pattern astronomers have since traced through historical records, suggesting it may erupt roughly every 80 years. Astronomer Bradley Schaefer, along with a team publishing research through 2023 in the Astrophysical Journal, confirmed the star's pre-eruption brightening behavior closely mirrors the pattern observed in the years leading up to its 1946 eruption, leading NASA to publicly state in 2024 that another eruption is expected imminently, potentially visible to the naked eye from Earth. Because the star sits 3,000 light-years away, the eruption itself, if the predicted timing is correct, would have technically already occurred in real time 3 millennia ago, and astronomers worldwide are currently, at this exact moment, simply waiting for light that may already be most of the way here to finally arrive and confirm what has, by every calculation, already happened. Number 5. One of the brightest and most recognizable stars visible from Earth is a blue supergiant burning through its fuel so quickly that astronomers consider its explosive death essentially guaranteed on a short cosmic timescale, and given how far away it sits, that death may have already taken place. Rigel, the brightest star in the constellation Orion, sits approximately 860 light-years from Earth and is classified as a blue supergiant, a category of star that burns through its nuclear fuel dramatically faster than smaller stars like our Sun due to its extreme mass, estimated at roughly 21 times that of the Sun. Astronomer Philip Massey, who has studied blue supergiants extensively throughout his career, including research published through the Lowell Observatory, has confirmed that stars of Rigel's specific mass and evolutionary stage are expected to end their lives as supernovae within the next few 100,000 to 1 million years, an extremely short window in stellar terms. Because Rigel sits 860 light-years away, any explosion occurring within the last 8.5 centuries would still be invisible to us today, meaning the star responsible for one of the most recognizable points of light in the night sky could have already ended, with the evidence of that ending currently still hundreds of years away from ever reaching Earth. Number 4. One star system sitting relatively close to Earth by cosmic standards is being carefully monitored specifically because astronomers have calculated it may eventually cross a precise mass threshold that guarantees total annihilation, and current models suggest that threshold could theoretically already have been crossed. Pegasi, located just 154 light-years from Earth, one of the closest star systems of its kind ever studied, is a binary system containing a white dwarf orbiting closely alongside a much larger companion star, gradually pulling material from its companion and slowly increasing its own mass over time, a process documented through decades of spectroscopic study. Physicist Subrahmanyan Chandrasekhar calculated in 1930 that a white dwarf exceeding approximately 1.4 times the mass of our Sun will inevitably detonate completely in a Type 1a supernova, a threshold now named after him. Researchers including physicist Bruce Drain at Princeton University have identified Pegasi as one of the nearest known systems capable of eventually crossing that exact threshold, though most calculations suggest the system will drift significantly farther from Earth before that point is reached, millions of years in the future. Because it sits only 154 light-years away, any detonation that had already occurred would reach Earth within a single human lifetime of when it happened, making it one of the very few systems on this list where a sudden confirmation could arrive with almost no astronomical delay at all. Number 3. One of the closest and most massive stars visible to the naked eye, is currently in the exact final stage of stellar evolution that immediately precedes a supernova, and astronomers openly acknowledge that if it already exploded within the last 5 centuries, we are still waiting for the proof. Antares, the brightest star in the constellation Scorpius, sits approximately 550 light-years from Earth and is classified as a red supergiant, a star roughly 700 times the diameter of our Sun, that has already exhausted the hydrogen fuel in its core, a stage of stellar life that, according to established stellar evolution models confirmed through decades of astrophysical research, typically precedes a supernova explosion by a relatively short span of astronomical time. Astronomers studying red supergiants, including work compiled by researchers at institutions like the European Southern Observatory using the Very Large Telescope, have confirmed Antares displays turbulent, irregular surface activity consistent with a star nearing the absolute end of its nuclear fusion capabilities, because it sits 550 light-years away, meaning the light we currently see left the star during the European Renaissance. Any explosion occurring since that time, an astronomically brief and entirely plausible window, given the star's advanced evolutionary stage, would still be completely invisible from Earth today, sitting somewhere in the roughly 5.5 centuries of darkness between the star's true current state and the outdated image of it we are still receiving. Number 2. In 2017, an astronomer made an extraordinarily specific public prediction that 2 stars locked in a death spiral would violently merge and explode by the year 2022. A forecast that placed a literal countdown clock on the death of a real star system, and the true outcome remains, to this day, formally unresolved. Astronomer Larry Molnar at Calvin University published research in 2017 analyzing KIC 9832207, a contact binary system located approximately 1,800 light-years from Earth, in which 2 stars are so close together they share a common outer atmosphere and are gradually spiraling inward toward each other. Molnar's team calculated, based on the shrinking orbital period observed over years of data, that the stars would collide and merge around the year 2022, producing a luminous red nova bright enough to become visible to the naked eye from Earth. The prediction generated significant attention across the astronomical community, specifically because it represented one of the first attempts ever made to forecast the exact timing of a stellar explosion years in advance. As of the predicted window, the dramatic naked eye brightening Molnar's team anticipated had not been definitively confirmed, to the degree originally hoped, and continued monitoring of the system's rapidly shrinking orbit remains ongoing. Because the system sits 1,800 light-years away, even if the predicted merger did occur exactly on schedule, confirmation of the true, complete outcome will not fully reach Earth for well over 1,000 years beyond the event itself, leaving humanity's very first attempt at predicting a stellar death still, in a very real sense, hanging in mid-collapse. Number 1. In late 2019, one of the most recognizable stars in the entire night sky dimmed so suddenly and so dramatically that professional astronomers around the world seriously debated, in real time and in published scientific literature, whether they were witnessing the final visible moments before it exploded. Betelgeuse, a red supergiant located approximately 700 light-years from Earth in the constellation Orion, is already known to be nearing the end of its life, though the exact timing remains uncertain and could occur anywhere within the next 100,000 years. Beginning in October 2019, the star lost more than 60% of its normal brightness by February 2020, the most significant and sudden dimming ever recorded for it, an event that made international headlines and prompted genuine scientific urgency. Astronomer Andrea Dupree at the Harvard-Smithsonian Center for Astrophysics led Hubble Space Telescope observations tracking the event, publishing findings in the Astrophysical Journal in 2021, concluding the dimming was most likely caused by a massive cloud of ejected stellar material temporarily blocking the star's light from reaching Earth, rather than an imminent explosion. Betelgeuse has since returned closer to its normal brightness, and the immediate danger appears to have passed for now. But Dupree's own research confirmed the star is shedding material more violently and unpredictably than previously understood. And because its light takes 700 years to reach us, meaning we are currently watching light that left the star in the early 1300s, there remains no way to rule out that Betelgeuse has already exploded at some point within the last 7 centuries, its true current fate already decided, and simply still in transit, crossing the final stretch of space between its death and the moment we finally see it happen. If you want to see more videos like this, click the video on screen now and make sure to subscribe.